Well, hello, my Sparkle students. Welcome to the new Sparkle Math Classroom. We are going to do lecture 4.1 and 4.2 today, since I can't be with you in the classroom, but here is our classroom. All right, so 4.1, now you know what I'm going to say. Get a piece of paper and pencil. We're going to write these down. You know when we're having all the fun up here. Come on. I'll wait. All right, good. All right, so this is section 4.1. We are evaluating. This whole chapter is on exponents. All right, so the first one, it says 3 raised to the 5th power, right? That's not 3 times 5. It's literally 3 multiplied by itself 5 times. But the beautiful part is you don't have to do 3 times 3 times 3 times 3 times 3 on your calculator. You can just punch it in, okay? And some of you will either have the caret key like this, or you'll have the raise it to key like that, or it sometimes is reversed like this. Okay, so you should have one of these 3 keys, caret key or the raise it to keys. All right, so like I said, this is 3 raised to the 5th power. So punch it in your calculator. Let's see what we get. 243, does that sound right? 243? You know it. Perfect. How about you guys try the next one for me? 7 to the 6th power. What do you get? Come on. Okay, it's 117,649. That sound about right? All right, excellent, excellent, excellent. How about this one? Why don't you try 5 to the 0 power? Go ahead and punch it in. Oh, you get 1, right? Excellent. 1. The truth is anything to the 0 power is 1. Okay, so we'll say this is 1. Okay. Now this one, we're going to view this one as negative 5 to the 0 power. Okay, the sign goes with the number. We're calling it negative 5 to the 0. That is also going to give us a 1. Okay. However, if you look at these two, remember how I said from chapter 1, chapter 2, parentheses mean something sometimes they don't. Here, remember we talked about this in chapter 2, this exponent only goes to the number and not the sign in front of it. So this one would be viewed as the opposite of 5 to the 0 power. This is actually going to give us a negative 1. Okay. All right, so we got 243 for 3 to the 5th. We got 117,649 from 7 to the 6th power. 5 to the 0 is 1. Negative 5 to the 0 is 1. And the opposite of 5 to the 0 is 1. Anything to the 0 power is 1. What if we did letters like this? X to the 0 power, 1. Negative x to the 0 power, 1. And then again, just like this last one, this negative does not go with it, so we're going to view this as a negative 1. Okay, excellent. Exponents, fun, fun, fun. Okay, the next thing it's going to ask you to evaluate is going to ask you to evaluate, and they're telling you the value of x here. They're saying x is negative 2. And here's our 2 situations. Again, this one has a parenthesis, this one does not. Okay, what they want you to do here is insert the negative 2, multiply it by 5, and then raise that to the 3rd power. So it would look like this. 5 times negative 2 to the 3rd power. So this is negative 10 to the 3rd power. So negative 10 times negative 10 times negative 10. We're looking at negative 1,000. Oops, running out of space on my makeshift board here. Okay. All right, excellent. All right, so again, I'm multiplying these first and then raising that to the 3rd power. But if you look at the second one here, okay, they don't want you to multiply this first. Remember the order of operations we talked about? Your exponents have to be done first. So this would be 5 times negative 2 to the 3rd power, okay? So it's only the negative 2 that's to the 3rd power and not the 5. So you would do this first, right? The order of operations. So negative 2 times negative 2 times negative 2 would be a negative 8. So 5 times a negative 8, we're looking at a negative 40. I'd say there's a big difference between a negative 1,000 and a negative 40. You know my saying, it's all about money, right? Yeah. All right, there we go. First page done. Okay, don't laugh at my makeshift board. You know how much I love a blackboard. Okay. So there are rules for exponents, and this happens to be the first one. This is the first exponent rule, and it is your product rule. Okay, and here's what you need to take away from that. When you multiply the letters, you add the exponents. Okay? You add the exponents. All right, so look at the first one. It says x squared times x to the 9th. Okay? They have the same base, so you keep the base. You add the exponents, you add the 2 and the 9, and your answer would be x to the 11th power. Okay? Now, unlike the last problem, they didn't tell you that x was -2 or it was 5 or what have you. So this is as far as you can take it, but you would know this. If you knew what x was, you'd be multiplying it by itself 11 times. Okay? Now, I don't know if you remember me telling you in chapter 3, I said in chapter 3 and chapter 4, you're going to really want to have your letters have numbers in front. Well, guess what? They also have exponents, right? So you see that this has a 3. You see that this has a 7. Even though you don't see this guy here as having an exponent, he does. He has a 1. Okay? So I feel like in chapter 4, it's to your advantage to go ahead and put that 1 in there so that you count it, because it is there. All right? So if they want me to multiply these out, I would keep my base of x. 3 plus 1 plus 7 is 11. Look at that, it's a coincidence. And that's all it is a coincidence. Okay? So the moral of the story here is we want to put that 1 in if we don't see it. It'll just make life easier. Okay, look at problem number 3. Okay, so you see that this guy has a cube, he has a square, he has a 5. He doesn't have anybody, but you know he does. He has a 1. Okay, so I feel like it's worth it to take the time to put that 1 in there. So you're going to put these guys together. X to the 3rd times x to the 5th. Again, when you multiply letters, you add their exponents. You're getting x to the 8th. Y squared times y to the 1st. Add them together, you get y cubed. Oops. I'm not used to writing with markers here. So my answer would be x to the 3rd times y cubed, right? There'd be 8 of these times 3 of these, if we knew what x was, if we knew what y was. And again, the coefficient here is a 1 and a 1. Okay, now, if you look at number 4, though, these do have coefficients that you see. Remember coefficient, the number in front of the variable. So we're going to multiply the 7 and the 2. 7 times 2, 14. Okay. Again, I'm going to make sure that all my letters have an exponent, so we're going to pop a 1 up here. So x to the 1st times x to the 3rd, x to the 4th. Okay, and we have y to the 4th times y to the 5th. We get y to the 9th. Okay. So your answer would be 14 times x to the 4th, there'd be 4 of these, times y to the 9th, there'd be 9 of those. Okay. All right, this is your first rule of exponents. When you multiply letters, you add your exponents. All right, let's see what we got on the next page. All right. The second rule, your second exponent rule. Okay, this is the quotient rule. And the quotient rule says this. When you divide letters, you subtract the exponents, right? You're subtracting the bottom from the top. Okay? Again, you want to have everybody have an exponent. Okay? So the first one here says x to the 5th divided by x squared. Okay, so they have the same base, the base of x. So I have x, I'm going to do 5 minus 2. So my answer is going to be x to the 3rd. X to the 3rd. Okay? Again, when you divide letters, you subtract their exponents. Okay, now look at problem number 2. You're going to see here, you see the 8. You do not see the 1 here. Okay, it's not illegal to put it. I'd put the 1 and make your life easier. All right, so we have 8 on top, we have 1 on the bottom. We're going to subtract those. And the answer would be x to the 7th. All right. Exciting, good stuff, right? Look, we're sparkling. We're sparkling. Okay, guys, don't let this rock your world. They just have 2 letters. That's okay. So it says x to the 5th divided by x squared. We're going to go ahead and subtract those. X cubed. And we have y to the 7th divided by y to the 3rd, y to the 4th. I know what you're thinking. After chapter 3, you're saying to yourself, chapter 3 was so hard. This is something's not right here. This seems too easy. No, it is. This is good. Let's enjoy it. This is good. This is good stuff. All right, so let's look at problem number 4. Again, do not let those coefficients rock your world. 10 divided by 2, 5. Okay, everybody has an exponent. Oh, I said that, but they don't. Let's pop a 1 on here. So we have 9 on top. We have 1 on the bottom. If we were subtracting them, we would get x to the 8th. Okay, we got 4 on top, we got 3 on the bottom. If I'm subtracting them, I'd have y to the first, okay? Now you can put the 1 there, but as I always tell you, if you were to go and check your answer in the back of the book, they would not put the 1 there. But if you did, it would not be wrong. I would never take off for that, right? It is technically there, they just don't put the 1. Just like when you have the letter X, remember we talked about this before? We said if you didn't see a number in front, you're to assume it's a 1. They don't put the 1 in there either. Okay, and the last one here. I should make you guys do it because you know that's what we usually do. 1 for me, 1 for you. But I'm here. This is my show, right? I'm the only one here. All right, so 16 divided by 4 is 4. All right, does everybody have an exponent? No, we need 1 here. We need a 1 here so we can see it. So we got 10 on top, we got 1 on the bottom, subtract them. You have 9. I got 3 on top, I got 1 on the bottom. If I subtract them, I would get 2. All right, so my answer would be 4x to the 9th, y squared. All right, this is your second exponent rule, the quotient rule, okay? Where you subtract exponents when you divide letters. All right, let's move on. I hope you guys are all doing well. I know the world's a little bit of a crazy place at the moment. It certainly is for me as well. I actually had to go back down to Florida to help my mom. The reason I was there over reading week was she had surgery, so I didn't want her to be by herself. But here I am with you guys. We're sparkling. All right, so this is your third exponent rule. This is your negative exponents. Okay, we're not technically allowed to leave negative exponents in our final answer unless it's scientific notation, and that is definitely coming. All right, so what I always think of it is this way. I always make everything a fraction. You know how I love fractions. And then I look to see where it's negative. And wherever it's negative, I'm going to move its location. And you really just have 2 locations. You have an upstairs, a downstairs, or in the math world, a numerator or a denominator. Okay, so look at the first one. All right. So you see it's x to the negative 3. So technically, if I were to make this a fraction, okay, it would be like that. So it would be negative up on the top. Okay, so all I would have to do to lose its negativity is move its location. All right, so it's negative up on the top. I'm going to move it down. Okay, so it's a negative 3 on top. When I move it down, it becomes a positive 3. And technically there was a 1 here, so I'm going to leave the 1 up here. You can't just leave nothing there. Okay, so x to the negative 3, if they're asking me to evaluate it, and they are, my final answer would be 1 over x cubed. Now, if they told you what x was, then you would be able to go further. Okay, but at this point in chapter 4, they're not really giving you a whole bunch of what the x values are. All right, guys, here we go. Okay, so if you look at problem number 2, it's negative on the bottom in the denominator. So all I have to do to lose its negativity is pop it up on the top. Okay, so it's going to come up like this. Okay, so it goes from 1 over x to the negative 3 on the bottom. I'm just going to move it up top. Now, technically, it would be over 1, right? But do we ever really show that 1? We don't usually, right? So if you just wrote x to the 3rd, that is what the book would have as the final answer, okay? But I would not mark off if you put it over a 1, because technically it is, right? All right, let's look at the third problem here. So this is 4 to the negative 2. This isn't 4 squared, this is 4 to the negative 2. So what I'm going to do is I'm going to move its location, because right now it's on top, right? So I'm going to move it down, okay, like that. Okay, so it's 4 to the negative 2 up here. I'm popping it down. And then I'm going to go ahead and evaluate it, because we can say what 4 squared is. So the final answer here is 1. Remember, it's not 4 times 2, it's 4 times 4. So it's 1/16. Okay, hope this is making sense to you. I feel like it would be. Okay, now, if you look at the last problem on this section here, okay, you'll say to yourself, well, I'm looking at it, I don't even see anything negative. That's true. That's true. But if we were to reference back to the second rule, and the second rule says that when you divide, you subtract, so we'll do that. Okay, we do it in red. I like them. I like having different color markers. All right, so here's my base of x. Okay, the second rule would say I would subtract them, right? So I would say 3 subtract 7, which would give me a negative 4. Okay, right? 3 take away 7. Now technically this would be up on the top, right? Because whenever you divide, that number is automatically up on the top. And we just got done saying, just got done saying you can't leave the negative on top, or you can't leave a negative anywhere. So we're just gonna move its location. So it becomes 1 over x to the 4th, okay? And again, they're not giving you enough information like the last one. You can't give me numbers like this. What you can say is, though, your final answer would be 1 divided by 4 of these, right? X times x times x times x, whatever x would be. Okay, excellent. All right, guys, let's look at problem number 5. Now, technically, I'm going to make this a fraction by putting it over 1. Okay, these are obviously 2 different letters, apples and oranges, right? This is A, this is B. Now, A has an exponent of a positive 1. He is fine where he's at, okay? We're leaving him right there. So the A is going to stay up in the numerator, because he can. And then all we're going to do is take this B to the negative 2, and we're going to move him down, and he becomes B squared. All right, so again, before we go further, you can make anything a fraction. I've said that forever, okay? Especially with these guys. And then anything that's negative, just move its location. And then see if you can reduce it or go further. All right, let's look at problem number 6. All right, again, I'm going to put it over 1 so that I can see that everybody's upstairs. Okay, now he has an exponent of 2, exponent of negative 4. His exponent is a 1. It doesn't really even matter for him at this juncture. It will matter in the future, and I'll tell you when that is. Okay, but now some of you, I always ask when we're in class, and we're not obviously right together right this moment, but you're watching this and hopefully gathering what you need from it. Okay. I would say that, decide what you have to move and what you want to stay. So this negative 3, he's fine right where he's at. He is a negative number, not a negative exponent. Okay, so the negative 3 is going to stay right on top because he can. The c to the negative 4, he's going to move down and become a positive. And then the d squared, he's going to stay right where he's at. And then that will be your final answer. Your final answer would be negative 3d squared over c to the 4th. Okay? They didn't tell you what d or c was, so you can't go any further. That's it. All right? Now look at the last one. You can do it 2 ways. Okay? You could go with the second way, which says basically that when you divide letters, you could subtract them. You could do that. You could do the second rule. Or you could say to yourself, well, hey, in the third rule, I can move this guy up, right? Because he's negative on the bottom. If I move him up, and he can join the one that's already up there, he comes up. Okay. So when he comes up, it becomes a positive. So it goes from a division problem to a multiplication. Multiplication being the first way, the first rule, you add the exponents. So your final answer here is x to the 3 plus 2, 5. All right, this is the third exponent rule. We are doing great, guys. I hope you are as well. Let's see what we got coming up. All right. Okay, the fourth exponent rule. Yay, yay, yay. So this is a power rule, and there's actually going to be 3 of those, right? This is the first one of the power rules, all right? And it basically says when you raise something from a power to a power, you multiply. You multiply, okay? So look, it says x squared, and it says there are 5 of these, right? So it'd be x squared, x squared, x squared, x squared, x squared. But you wouldn't want to have to do all that. You would just multiply them, right? So your answer then would be x 2 times 5, x to the 10. It's beautiful. It's beautiful. The hardest part I would say about chapter 4 is just keeping everything straight. There's a lot of rules, but you can do it. I have faith in you. All right, guys, how about the second one? You know I normally say you do that one, but why don't you go ahead and do it? Come on, you can do it. I know. I'll wait a second. Come on. You got it. You got it. Of course you got it. What is it? We're going with x to the 9 times 3 is 27. Beautiful. I know you're thinking, gosh, this stuff is just too easy. That's okay. It's okay. It's allowed to be. I promise. Okay, so don't let it rock your world when they're going to throw in a negative. That's okay. We'll deal with it. Do the multiplication first, right? So this is a y, right? Negative 5 times 7 would be a negative 35. Okay. Technically, this would be over 1. So we know from the last rule that we're going to move its location. So we're going to pop it down here, y to the 35 on the bottom, and a 1 on top. Got to have somebody on top. Okay, there you go. All right. So it's okay if you get a negative exponent, as you will, but then you're just going to move its location. And the last one, they're both negative on this row here. A to the negative 4, raise it to the negative 6. You multiply those, you get a to the positive 24. It's beautiful. Beautiful, beautiful, beautiful. All right. So obviously these are letters, right? Variables. Raised to a power to a power. So you can do the same thing with the number here. So this is a base of 3. It's 2 times 4. So this would be a base of 3. 2 times 4 is 8. Okay. But you can go all the way, right? This is as far as you can go here. This is as far as you can go, as far as you can go, as far as you can go. But you can tell me what 3 to the 8th power is. We're looking at 65, 61. Okay, so if you can go all the way, go all the way. All right, this guy. You know how we said we love zeros. Zeros make everything go fast. So this has a base of x. 2 times 0 is 0. Right, anything times 0 is 0. And what do we say about 0? Anything raised to the 0 power is 1. Sparkles. All right, guys. So we can do letters and raise them. We can do numbers like this. So this is 5 to the negative 2. It's raised to the 3rd power. All right, so it has a base of 5. Negative 2 times 3 is negative 6. Okay, we just said you can't leave it that way. So we're going to pop it over 1. So we know that it's up on the top. We're going to move its location. So it's going to come down and be positive like that. And then because we can, we're going to go all the way. Our final answer then would be 1 divided by, and 5 to the 6th power is 15,625. This is the final answer that we want, the one that's going to make us sparkle the most. All right, this is a power rule. Let's look at the next ones. Now, I would say the next ones are not the hardest, but they involve the most amount of work. Okay, so let's look at those. All right. Hope you guys get all the toilet paper you need. That is a crazy time in this world, isn't it? All right. Yeah, I went to buy some hand sanitizer. It was like, good luck with that. All right, guys, so this is the 5th rule, exponent rule. It's really just more of a power rule, and really the only thing that's different is that there's more stuff on the inside. Okay, more stuff on the inside. When we were doing a problem just a little bit ago, I said, oh, it was a negative 3, and I said, well, technically it's raised to the 1st power, but you didn't need it. And I was going to tell you when you need it. You need it now. Okay, and this rule here, this 5th exponent rule, you want everybody to have an exponent. Everybody, everybody, everybody. You thought you weren't going to hear that again, did you? Ha! So look, you want to pop a 1 on that 4. Okay, you want everybody inside this parenthesis to have an exponent because everybody is going to be affected. Okay, everybody is going to be affected by this 3. This is what I mean. Okay, so look at the base of 4, 1 times 3. So it's 4 to the 3rd. Yay. And then it's a base of x. 2 times 3 is 6. Okay, but you know you're not going to stop here because you can tell me what 4 to the 3rd power is, right? 64. This is your final answer. Your final answer is going to be 64 x to the 6th. Okay, beautiful. This is what really trips people up with this one. So you want to make sure that everybody has an exponent. That 4 needs that exponent. Okay, he already had one. Let's look at problem number 2. Okay, problem number 2, we want everybody to have an exponent. Let's pop a 1 on the 5. Let's pop a 1 on the y. So everybody's in the pool, everybody's playing. Okay, everybody gets affected by that 4. Everybody, everybody, everybody. All right, so it looks like this. So we got a base of 5, 1 times 4. So 5 to the 4th. We'll evaluate that in a second. Base of x, 2 times 4, 8. Base of y, 1 times 4, 4. And base of z, 3 times 4 is 12. Okay, now my final answer, because I can do 5 to the 4th. And I believe that's 625. It is indeed. All right, so here's my final answer. 625 x to the 8th, y to the 4th, z to the 12th. Woo! Some beautiful numbers, right? Why don't you guys try this one? Come on. You know me having all the fun here. Come on. Pop a 1 on the 6, okay? Apply that -2 to everybody. Oh, wait a minute. Go ahead. I'm not in any rush. Come on. Come on. See, I don't get on my blackboard, I don't get markers like this. I like the markers. All right, guys, so we made sure that everybody has an exponent. We're going to apply that -2 to each one of these, right? So it looks like this. Base of 6, 1 times -2. 6 to the -2. Okay. Base of x. Hey, those are both negative. -4 times -2, positive 8. All right. And base of y, 5 times -2, -10. Okay, now technically this is all over 1. All over 1, okay? These guys both have negative exponents, so we know they're going to move their location. I'm going to write this over here because I'm running out of space, just like I usually do on the board. All right, so here's my fraction. Okay, so the 6 to the -2 is going to come down right here. He becomes positive. Hey, the x to the 8th was fine where he was. He's going to be up here being happy and being positive, like the rest of us in this world. Positive. And then we're going to move this guy down so that he becomes positive as well. You know what I'm going to say. That's not my final answer because you can evaluate that 6 squared. Ooh. Oh my goodness, is my marker dying on me? That's all right. We don't need that one. Here we go. Okay, so my final answer is going to be x to the 8th. Woo! 6 squared, 36. Y to the 10th. Ooh, that's sloppy. Sorry. All right, so so we made sure, just recapping, we went over this problem here. We popped a 1 on the 6. We multiplied everybody by -2. We said, hey, who has to move their location? We moved their location. And then our final answer is x to the 8th divided by 36, y to the 10th. Good stuff. Good stuff. All right, the last one under this rule, problem number 4. Again, I would want to make sure that everybody has an exponent, so I pop a 1 on here. Now, here's the difference with this guy. He is viewed as a -8, so this is one unit. They are together. The negative and the 8 are together, okay, and they're both squared. This is a -2, this is a -3. All right, so it looks like this, just applying that 2 to everybody. All right, I'm going to put him like this, because I'm going to make sure in my mind that I know that that's a -8. 1 times 2 is 2, so it's -8 squared, x to the -4, right? I'm just multiplying the -2 and the 2, and then y, -3 times 2 is a -6. Okay, now technically this would all be over 1. Okay. Now again, what I was saying about negative exponents are what move. This guy doesn't move. He's a negative number, not a negative exponent. These guys have to move out of town. Okay, so here's my final answer. Ready? I know you're ready. All right, -8 squared is -8 times -8. That's 64. He stays right on top. He's up in the numerator. Okay. This guy comes down. This guy comes down. So we get x to the 4th, y to the 6th. It's beautiful, right? You know that. I always say that. It sparkles. All right. So this is our 5th exponent rule. Probably the most work out of all the exponent rules, but we got one more to chat about, so let's do that right now. Okay, here we go. Whew. Okay, so this is your 6th exponent rule, and really all it is it's fractional. That's all. It's still a power to a power, and this is the rule, and these can be found in your book as well, in section 4.1 and 4.2, which I highly encourage you to read. Okay, so the only difference, like I said, these are fractional, and I know how much you love fractions. We got this. You ready? Come on, we got this. Here we go. So it's a base of x. 2 times 3, 6. Beautiful. Base of y. 4 times 3, 12. Can I subtract them? Is that what you think? What do you think? Can I? Ha! I already heard somebody say, no, Ms. Wolf, of course you can't. Why can't I? Because they're different letters. Now, if they were the same letter, right, if they were both x's or they were both y's, then I could use the second way, or excuse me, the second rule, and subtract them. But they're not. That's an X, that's a Y, that's it. They're done. Okay? There'd be 6 of these on top and there'd be 12 of those on the bottom. But we don't know what X and Y are. All right, let's do this guy. So again, you want to make sure that everybody inside the parentheses has an exponent. So let's pop a 1 on that 5. Everybody else has one. They sure do. And also you'll notice here, now I'm not trying to trick you, but this is just what happens, right? So the exponent here on top is a 2 and the exponent on the bottom is a 3. Do not let this rock your world. It's okay. Treat them separately and then assess the situation. So it looks like this. Here we go. Base of 5, 1 times 2, 5 squared. We got this. Base of x, 4 times 2, 8. Beautiful. Over. Base of y, 3 times 2 is 6. Hold your, don't stop. Because you're saying, what else? That's an x, that's a y. Yes, but can't you tell me what 5 squared is? I know you can. 5 squared would be 25, x to the 8th over y to the 6th. There you go, guys. We're making chapter 4 just sparkle and come to life. Got this. Got this. We got this. All right, so look at this guy. This is a y to the 3 over 5. Now, he doesn't have an exponent, and everybody has to have an exponent. In fact, just like I said, chapter 4 across the board, just make everybody have an exponent. Okay? If you don't use it, that's fine. But it's good to have. All right, so doing this gives me multiplying. This would be y to the negative 6 over 5 to the negative 2. Right? I'm just multiplying the exponents, right? 3 times negative 2, 1 times negative 2. They're both negative, so I'm going to go ahead and flip them so that they become positive. So this guy comes up, this guy comes down, and you're saying, that's it, I'm good. Can't you tell me what that is? Yes, you can. 5 squared is 25 over y to the 6th. That would be my final answer, the one that would make me sparkle the most. All right, guys, how about this one? I'm going to go ahead and pop a 1 on this and pop a 1 on this, okay, because I want everybody to have an exponent. I mean, you can reduce the 6 and the 4, but I personally like to just go ahead and do all the math and then worry about reducing later, okay? Because if we had had different exponents on the top and the bottom, that could change things. So I think just reduce at the end. I think that's easier, personally. All right, so here we go. We're going to apply that negative 2 to everybody. Everybody's got an exponent now. So 6, 1 times negative 2, negative 2, x. Negative 4 times negative 2 is a positive 8. Okay? We're going to apply that negative 2 on the bottom. So this is a base of 4. 1 times negative 2, negative 2. And a base of x, 5 times negative 2, negative 10. Okay, so that would be my first step. Well, actually my second step. My first step would be making sure that everybody has an exponent. Okay, my second step would be applying that negative 2 to everybody. My third step would be, hey, move people. Get everybody positive, right? We want positive vibes here. I want all my exponents to be positive. So here we go. Whew. I do miss my chalkboard, but I do like the markers. Okay, so I'm going to move this 6 squared down. I'm going to move the 4 squared up, okay, because I want everybody to be positive. I moved him down. I moved him up. The x to the 8th was fine where he was. And I'm going to move that x to the negative 10 up. So first, get everybody with an exponent. Apply that negative 2 to everybody. Now I'm going to go ahead and do the math here. All right, so 4 squared is 16. I would add these, x to the 18. And 6 squared would be 36. Okay, I can divide both of these by 4. You know why? Why? What do I say about your fractions? You always reduce your fractions, always. So I'm going to divide this by 4. I'm going to divide this by 4. So here's my final answer. Dividing that 16 by 4 would give me a 4. X to the 18th. Over 36 divided by 4 would be 9. Again, you can reduce in the beginning. I personally just like to reduce at the end. I feel like it's less messy that way. So that is our 6 exponent rule. There are 6, at least. Okay? And finally, let's talk about scientific notation. Okay, scientific notation. Most of the numbers that you will encounter in your everyday life, like this one, 78,000. This is what they call standard notation. This guy right now is in standard. And that's what most of your numbers are going to be in. Standard notation. Standard, okay? But say if you take a science class or something, they're going to ask you to convert it to scientific notation, which is really just a shorthand way of writing things. Basically, it's just to get rid of the zeros, okay? So here's what we're going to do. Most of you are probably familiar with this, but let's just talk about it. So where's my decimal point? My decimal point is right here. It's located at the very end. I'm going to move that decimal point to the left, and I'm going to move it so that there's just one number that's in front of it. And the catch is it can't be 0. So it has to be a number between 1 and 9. We got this, right? Here's what we're going to do. We're going to go 1, 2, 3, 4. 4 places, right? We're going to rewrite this number as 7.8, right? We're going to drop off those zeros because that's what we're doing. We're going to replace those zeros with a base of 10. So it's always going to be times 10. And here's the fun part. The exponent is the number of places that you moved. What did I say I moved? 4? Let's just double check that, right? So I went 1, 2, 3, 4. So the number would be 7.8 times 10 to the 4th power. Now listen, if these were money, because you know I always talk about money, right? Positive and negatives about money. These would be exactly the same thing. 78,000 and 7.8 times 10 to the 4th, same thing. Just this is in standard, this is in scientific. This would be easier if you had like 30 calculations that you had to do, right? And then we would reduce everything there, okay? How about this guy? Look at all those zeros. Would you want to punch in all those zeros on your calculator? Heck no. Here's my decimal point right here. Whoop, way back here. We're going all the way to this side of the town. We're going between the 1 and the 4. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. My number is 1.4 times 10 to the 8th. Now, I know some of you, because you always do in class, in the past, they'll say, well, how come it's not 14? Because, again, we're always moving the decimal so that there's just one digit that's in front of it. So it's going to be a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9. Okay, it can't be 0. All right, so we're always going to move it so there's just one digit in front of it. Okay. Now you're maybe looking at number 3. Maybe you're already eyeballing it and you're saying, she's trying to trick us. Well, maybe. No, I wouldn't try to do that. You know me. This would be considered standard. Now, if I wanted to make it scientific, okay, I would move the decimal point anywhere, so it'd be 7.49. Nothing's changed there. There's not even any zeros to drop off. But if I'm putting in scientific notation, I'd say times 10, because it's always times 10, right? It's a number times 10 with the exponent. Did I move anywhere? I didn't. So 0. And if you remember back, so like 10 minutes ago, I said that anything raised to the 0 power is 1, and 7.49 times 1 is still 7.49. So the point that I'm trying to make is, if you're asked to put it in scientific notation, you can. It seems kind of silly because it's actually more work, right? Whereas here you're dropping off the zeros, here you're dropping off the zeros, but technically you can do it. And by raising it to the 0 power, that makes it a 1, then nothing has changed. All right. Now, say you were taking a physics or a chemistry or biology class. You would have big numbers, but you'd also have really small numbers, like